and good afternoon, everyone, or good morning, depending on where you are across the country. I know we were talking with Keith earlier, kind of pre-show. Learned that he's out on the West Coast, so he's with us bright and early today. But if you're on the East, hopefully you enjoy your lunch hour here, and thank you for taking the time to spend it with us. This is another ATS University, and I'm Zach Allison with ATS. If it's your first time at an ATS University, thank you for taking the time to learn with us. We run a near weekly webinar session on a variety of topics, whether it be an in-depth kind of honestly new product overview, like we're talking about today with the commercial leak defense systems. We'll also have application-focused discussions. We may have more generic industry as a whole, or how to write a spec in the construction industry, new features, new tools that are on the spec tools, on how you can find and select products. If you're unfamiliar with ATS, we are essentially a house of brands, all organized into new configuration and product selection tools that are available for you to organize and store your projects and masters and make selections so you get the right product into the right application. At the end of the day, we help you get the specific configuration of a product that you're looking for, not just the generic model. So something like we're talking about today with these leak defense systems, at the end of the session, I'll show you how you could find those products on the ATS SpecTool or the Watts Spec Hub, depending on which tool you're utilizing. And if you have any questions after this on understanding the spec tool more, please feel free to reach out to me. If you would like a session like this specifically for your firm, maybe you need a deeper dive and have some extra questions, we can certainly help set up a lunch and learn, either with Keith again or any of our Watts colleagues, to help you understand the product in more detail. So I guess without any further ado, I guess one other thing, I always forget this. We do typically send out our certificates of attendance on Fridays, so that you are able to self-report if need be. That's for more of our general sessions. But this being an ASPE accredited CEU, we'll be providing the list of attendees over to Keith and the Watts marketing team. They'll be able to send out their certificates afterwards as well. And as always, these are being recorded, so we have muted everyone upon entry. But if you have questions along the way, please feel free to pop them into the Q&A chat. I'll raise them up to Keith as we go so that we can stay on topic and ask our questions while the topic's still relevant. So yeah, now without any further ado, I'll pass it over to you, Keith. Thanks for joining us today.
Yeah, thanks, Zach. Keith Zander here, product manager with Sentinel. Been with Sentinel probably, going on probably 7 or 8 years now. Used to be with a division of Emerson Electric, doing data center design with HVAC and electrical systems, aka Vertiv now today, if you guys are familiar with that organization. So definitely familiar with dealing with specifying community, consulting engineer, etc. So taking that experience here and moving it over to the commercial leak defense, leak protection, leak identification type market. And let's get right down into it. Got any questions, feel free. As you see here, course approved for ASPE CEU. We'll give everyone's names. If you don't get the certification credits there, then obviously send us an email there. End of this course, you'll be able to explain why leak detection is critical in multifamily and commercial structures. I'm actually quite impressed with the Canadian engineering team, architectural team up north of the border there. They seem to be more in tune with this type of structure and understanding. It could be because you guys have the potential for more frozen pipes up there. Maybe because there's some legal issues, sustainability issues, but that's what we're going to try to understand here. There are a number of different companies. We're going to try to get you an awareness of how to evaluate leak detection and the different types of products. We're going to identify the buildings with the greatest risk for leaks and water damage. I could easily say, hey, all the buildings, put them in all the buildings, which is actually my contention. We do have obviously a greater risk of leaks in certain types of buildings. We're going to identify what those are. We're going to describe the different tier levels of leak detection systems. Here again, this allows you to compare one type of system to others. You can buy things off of Amazon all the way to custom build type systems. So we're going to show you kind of the arena that we work in, and then you're going to be able to determine the advantages and disadvantages based on what your customer actually needs, your basis of spec, and then how you typically like to do it, doing a cost trade-off between cost and performance. We're going to highlight the theory of operation of flow-based leak detection system. Some of you may not be aware of the differences, so we're going to talk about outside of the pipe water detection and inside the pipe water detection. Summarize the relevant consideration for building owners, specifying engineers, HVAC contractors, insurance carriers, and designing, specifying leak protection system, and then give you some ROI arguments and talking points in regards to talking to your customers. Why should you install it? What is the ROI? How can you evaluate it? So what this course is not about, it's not about leak detection, walking around with the acoustics, with the sonar, trying to find leaks. You see a puddle, you feel warm water, you don't know where it's at, underground, above ground, whatever it is. So this is not what this course is about, just to kind of clear the air there. Essentially what leak protection is, it's a protective device, it's a safety device, it's a protective device to protect really personnel and property. So you guys are familiar with everything that's mandated by law: smoke detectors, water backflow to protect the domestic water supply, electrical circuit breaker, all these things are mandated in all jurisdictions. Egress safety. Currently, there are not many jurisdictions that mandate automatic water shutoff protection devices. But so this, you can basically see this as the smoke detector for water, or the circuit breaker for water, or the protector for the water system. What oftentimes people forget is, what is the human safety issue involved with this? Well, if you walk into Walmart or Target or some type of a store, anytime that there's water, some kind of a breakage, or somebody broke something, they immediately send someone over there. They put the cones out, they guard that area because they realize that it's a legal risk. You can get the attorneys involved. And then, of course, if you start getting water in the electrical system, you've got a life safety issue in regards to electrical protection there and human harm. What I'm showing you here is a little bit of the bullet point on the leak defense type system, giving you some components, some basic components here, and giving you a simple diagram to help you understand. So everything in the diagram on the right-hand side there in blue font is something that is a part of the leak defense system, leak protection systems that you as a specifying engineer can specify there. The leak protection system is an ultra low flow, all the way to a high flow detection sensor and a pipe. So we're talking about an end pipe nature there on the left-hand side there. This section over here, we've got a sensor, we've got an automatic shutoff actuator. You've got a ball valve showing in this application. Then you have a spring check valve here. And I'm going to go through those components and tell you why those are important. So you've got the automatic remote water shutoff. You've got leak alert both locally. So you see the control panel right there. You'll get the bells and whistles right there. And then you've got relay outputs on this device, or Modbus connectivity, BMS, BAS connectivity, common alarm connectivity with what we call and what most cogent competitors interface with. Relay outputs there. You can program the relays to tell you whether or not the valve is on or off, whether the system's in alarm or not in alarm, or you can get into more depth in terms of what type of flow you have and things like that. The other thing that this display shows right here, probably 90%, 99% of the designs that most folks do have got recirculation on the hot water side. So you got a recirculation pump right there. And so you got devices that can, via relays and control systems, shut off that recirculation pump if this valve gets shut off. So two things that this solves, just to give you a little simple application here. If you get a leak somewhere in the system and you automatically shut the water off, you don't want that recirculation pump to feed that leak. You don't want that recirculation pump to feed whatever amount of storage that you've got, whether you've got, 50 gallons in a residential, 40 gallons in a residential application, or whether you've got 50,000 gallons, up on the top of the roof for water storage, for your fire suppression or whatever. So that's just kind of a simple application, controls, monitoring on site, automatic shut off. And then down here, what we show is any accessories that you want. Point floor sensors, it's what we call outside of the pipe water detection. Point sensors here that will then automatically shut this off without any time delay. So for instance, this device right here may have a time delay on it. You may have a 20-minute timer saying, hey, I know water in this particular application should only be running for 4, 5, 6 minutes the longest. So if it runs for 10, 12, 14, 16 minutes, I want to automatically shut it off. Or you may have a quantitative value, which you say, I don't want any more water over the course of an hour running over and above X number of gallons. So all those controls can be set in there. 9 reasons to design leak detection on every project. So water is the #1 cause of property loss damages. Insurance companies are the primary driver for this business. Most customers will not suggest that the architect MEP designs in the system unless you bring it up, unless you make the argument that, hey, it's necessary for a number of different reasons. #1, sooner or later, you're going to have a leak. Sooner or later, the insurance company is going to get a claim. Sooner or later, the insurance company is going to tell you, you must install a leak protection system in this structure in order to maintain your insurability of the building, or we shut your system, the water protection portion of that insurance policy off, and you're self-insured, which a lot of people are these days because they file so many claims. The average commercial claim is about $90,000. How do we calculate that? I'll show you on the next slide. Average residential claim, and you can pick up numbers from different studies. So it kind of ranges plus or minus 10, 20% kind of on these values, depending on which study you're looking at. One important thing is water claims from a quantitative standpoint are more than fire and theft combined. So if you think of the risk of fire, theft. You add those two together on the quantity of claims, and it doesn't equal up to the water claims that you've got for this type of damage claim. And then if you don't see the claim, you don't see the leak in the behind the wall, above the ceiling, under the slab, you start getting the mold, and you can add about 10 times to those claims. And a lot of the insurance companies, again, are excluding mold. So the customers got to look at his policy, got to shop around. So the nice thing about installing leak detection is it allows them to shop around, showing that the insurance companies that you've mitigated those claims in some respect. And many of the insurance companies, depending on the type of property, will give you discounts for that. Extreme damage occurs nights and weekends. So that's the issue is when the water starts pouring down, if you do not have personnel there to see that leak, then you can't respond to it unless you've got some kind of automatic water shutoff. So water claims like mold are becoming exclusions. We talked about that. Every building will eventually have a leak sometime down the road. So what we try to do for specifying engineers, architects, is we say, engineer this on every building that you've got. Come up, figure out what the budget is. Let the customer, whoever, developer, project manager, let the customer pull that out, value engineer that out of the project if you want. And the nice thing about that is when they do have leaks and when they do call you to do upgrades on the system, you've already got it designed in. You've already got the locations marked out. You've already got the piping set up to do strategic shutoffs at the necessary high-risk locations. And it's a very simple type of an operation to go in and add those back into the project if you've done it up front. And then 75% of all the claims by dollar amount are related to leaks. So here again, that's sort of the big drivers. And then you got about 1 trillion gallons wasted every year due to leaks, depending on which location above or below border that you're looking at here. Again, this is another slide just to substantiate some of the specs that I just threw out there. Number of water claims by claim dollars and by claim frequency, sort of validate that. So whether you're looking at Zurich or whether you're looking at some of the other reporting and insurance companies there, you'll get a few other values there. What most people do is, at least down kind of below the border, is they have leaks. They come in, they say, okay, give us a proposal, put the spec together, quote us out, and then they say, yeah, well, that's too much money. We'll just roll the dice, which basically means having no leak protection at all. Again, it's the human eyes and ears when they can hear water coming out of the pipes, when they can see water coming out of the pipes. That's their leak detection strategy. So on a high rise, mid rise, if you've got a concierge, you've got the business continuity disruption is real. Relying upon humans to notice the leak before the significant damage occurs, it's a very poor plan. The legal risk of sick buildings, so yeah, you've got the legal risk of slip and fall and electrocution, but you also have sick buildings potentially, and obviously that's a big issue. Sustainability, water abuse, new laws. Everybody wants to be good stewards of the earth these days. Consulting, your job is to identify the risk, call it out to the developer, mitigate that risk through proper design. Some of the things that people don't understand from a risk standpoint is open windows. I mean, obviously up north, you guys realize that piece of the puzzle, but we got called in on a job one time and had a condo owner, I think, leave the condo, leave the window open in whatever it was, October, November, didn't get back until the pipes froze up and caused significant damage. Abandoned water lines. We see this quite often where the water line is still full of water. They cap it off. They don't know it's there on a T or a branch. Eventually it corrodes or gets too much pressure and blows out. And I've shown some fun little pictures there. You guys may have seen New York City the last 6 months or so. We try to pull some fun pictures out there where the water is blowing straight out of the, it's easier to open a window and let it blow out of the 6th floor than to drop down all 6 floors and create more damage. So I think that's really what they were doing in that scenario. And then again, corroded pipes, old pipes. It's a lot cheaper really to put a leak detection system in than do a complete repipe in a building. So when you do that evaluation, oftentimes condo owners, HOA locations, they don't have enough money to do a full repipe in the building. And they find this cheaper to put a leak defense system in, leak protection system. One of the fun little stats we put out, we had a 2-inch hot water line, 180 degrees, failed in a large location down here in the States, $50 million and a 9-month delay in the project. So, I like to quote those things. So buildings with increased risk of leaks here. New construction, obviously you got a shakedown period on that. Some of the pipes, when you do pressure testing, may hold the initial pressure test, and then they expand, contract over time, summer, winter, and then they let loose. So we see that quite often. And you're vacant before you lease the building out completely, so you don't have people there locally to see whether or not someone, contractor, etc., left a pipe opening, doing a repair, or someone's showing the apartment complex or something, and someone goes in and opens a valve and leaves and don't know the valve's still open, and the sink, it gets clogged up, overflows, things like that. Multi-tenant residential hospitality. So the big issue here is how many fixtures, how many locations do you have in this facility that has the risk of having leaks? Primarily you get a straight pipe, good continuity of pipe. Let's say PEX pipe for 200 feet. The odds of it having a leak, between the connections are not very high. So typically it's where you have those connections, where you have those joints, where you have that high pressure go in there. So multi-tenant residential hospitality healthcare, those type of things. Geographic climate extremes, that's more kind of down below the border here, where we don't insulate well down here. So you get some temperature deviations, high and low, that you don't expect, and 50, 100-year freezes, different locations, high risk. High fixture to square foot ratio. So when you think about how many, what type of locations, retail locations have high fixture to square foot ratios. You think of hair salons, you think of medical buildings, hospitals, universities, laboratories, things like that. So when you have a high degree of fixture to square foot ratio, definitely, if you don't do it on the other, warehouse projects, let's say where you just have two bathrooms and 1 million square feet of warehouse space, clearly your risk factor is not as high there. Retrofits. So we're seeing buildings nowadays that are 10, 12, 13 years old that are starting to have leaks. So depending on what type of fixtures they get, connectors, couplers they get, and sad to say, down here where I'm at, California, Southern California, San Diego, we got 2 buildings and two big projects down here where they sourced some stuff from China, didn't do their QC well, and they had their bolts on their couplers blow off, so they had to spend millions of dollars going in and replacing this stuff, and obviously had a few $100,000 to $500,000 in claims before they identified what that looks like and that sort of thing. So retrofits, again, I talked about that a little bit before. Raised floors. Why are raised floors kind of an issue? Well, raised floors, think about it. A lot of the mechanicals and pipes without a raised floor go in the ceilings. And you get water leak in the ceiling, comes down, either is exposed or it goes through your ceiling tile and it goes onto your desk, computers, things like that. You see it, you respond to it. Whereas on a raised floor type application where a lot of your mechanicals and plumbing and electricals going underneath the raised floor, oftentimes you don't see that until it leaks in an adjacent hallway. It leaks outside the building wall. I've seen that happen quite often, or it leaks obviously down through perforations down to the floors down below. So that kind of gives you an idea of the risk factors there. This chart basically says 78% of all the water that you purchase through the meter is used inside the building. So a lot of people say, well, most of my water is used outside for landscaping. The general consensus is about 20 to 25% outside, 75, 80% inside use. So we can argue, what uses the most water, what type of fixtures inside the facility. It's going to depend on geography, how you do your HVAC and all that kind of stuff. So I won't spend too much time on that slide there. Again, here's another fun little picture here in New York City. So this is not like a unique one-time thing. 33 sources of leaks in. So this is a list of all your fixtures, just things that you forget about, your fish tanks, your soda machines, your storm pumps, coffee makers, those type things. You know what your list is on your mechanical schedule for all those devices there. I won't go over one by one on those. And then residential, basically the same type of things, a little bit less of a list on residential versus commercial. But a lot of the spaces that you design are going to have mixed use. You're going to retail down below, multifamily up top. So just consider that. Historically, people have used really 3 different types of tactics. Call it tactic A, P, or F. A for single appliance shut off, maybe a water heater, maybe a washing machine. P for POD, outside the pipe, water detection, floor sensors, hockey pucks around hot water heaters, point sensors. And you may just have it alarm go off, or you may have it automatically shut off the source of that water. And then tactic F, flow monitoring. It's kind of the new kid on the block, the last, 5, 10, 15 years. Our company's been around for about almost 20 now. So it's been around a long time. It's just people have not kind of taken up and understood really how that works. So it's just, time and trip and algorithms and normal water flow and abnormal water flow. We'll talk about that a little bit more in a second. Here's the thing that I'm kind of proud of here, the 5-tier levels of solution and applications. So let's just go over this, spend a few minutes here. Tier 1 through tier 5. Tier 1, it's the lowest cost. Tier 5, highest cost. So you see that in tier 1, least effective. Tier 5, most effective. Tier 1 on the left-hand side there, detection and alert without valve shutoff. So it's the lowest price. It's what we call outside the pipe water detection. And insurance companies have dictated that, just in general, it's about 10 to 15% effective. What does that mean? That means 85 to 90% of the time, when you get a leak, when these devices go off, when they start buzzing and beeping, you're still going to have to file a water claim. The damage is going to be over and above your deductible. 90% of the time on a tier 1 application. You can double that effectiveness by going to tier 2 with automatic water shutoff. So you have outside water detection, a rope, point sensors under sinks, bathrooms, toilets, hot water heaters, water tanks, whatever your risk factor deems to be. And if you automatically shut that water off, you double that effectiveness. So you're about 15 to 30% effective. And then you start getting to flow monitoring. Inside the pipe, flow monitoring, you characterize what your normal water flow is. You send notifications when it becomes abnormal. So we call that inside the pipe, tier 3, flow monitoring only without shutoff. So you may have people that says, I don't want you to shut my water off, or my piping diagrams. Here's the biggest issue. The piping, let's say in a retrofit scenario where I've got stacks and risers going up to multifamily. And if I shut one riser off, I'm shutting the kitchens off on 10 floors or 20 floors or 30 floors. And so the facility manager says, I don't want to do that. I don't want to automatically shut the water off. So we don't. We notify you. And then if you start seeing water come down the elevator shaft, okay, well, maybe it's okay to shut 10 guys' water off. So 10 to 40% effective, depending on how you set it, depending on how you train your people. And so really, to make those least effective areas up top, what people typically do is they say, okay, well, I'm going to train my concierge. I'm going to train my facility manager. I'm going to show him where all the valves are. I'm going to make him, anytime he sees water, he gets notification of water, know where the source of that water is. Gosh, it works probably for 6 months. But after you change personnel, or you come in and do a change in your piping, your maps change, your as-builts change. And so it's not that good. So tier 4, so you have inside the pipe flow monitoring, you have automatic water shutoff, and notification. So you kind of have the best of most worlds. And then we jump to tier 5. You have what we call both, inside the pipe and outside the pipe. And it roughly, insurance companies have said, it's about 95% plus effectiveness if everything is installed right. That's the big caveat. If you test, if you make sure it's still working, if you make sure the customer did not turn the valve off on manual when the electricity went off and stick it back on the auto, make sure that they didn't unplug the plugs when they were trying to clear the alarm because they didn't know what buttons to push. You just have to go in every quarter, every 6 months, every 3, once a year, twice a year, test it, make sure it's all working, or you're going to get caught without that perfect plan. Tactic A, just a little bit more info on that. Again, some more pictures there, how they do that application, different ways of doing appliance shutoff. You got your control unit with your shutoff, and then over here on the right, do I want to cut off the power to my water heaters? Do I want to cut off the gas to my water heaters? The source of that power, so I can shut the valve off. But do I have a low, low gas or no gas or low level of automatic shutoff? If I don't, I may want some other kind of protection down here. So, you guys are familiar with that typically, but more and more, when you see the necessity, you see more of the leaks, customers experience those leaks, you get somebody that's been a facility manager a long time, he knows what he wants there in his project, or you get a lot of the large CBREs and property developers over time, they've been burnt quite a bit. Tactic P, outside of the pipe, point of leak detection, water detection cable. You can buy cheap stuff off Amazon for 10, 20 bucks. That doesn't go to Wi-Fi, doesn't go to any kind of connectivity. I mean, I've seen multifamily high-rise operations go to Amazon and put systems in. Why? Because their goofy insurance company accepts it. And then 6 months later, a year and a half later, they try to add on to the system. Oh, sorry, that company's out of business. So you obviously want to put a reputable company in, somebody that's been in business for a long time, knows what they're looking at. So essentially, that kind of gives you some pluses or minuses there on what to look for in the feature set. Tactic F, flow monitoring, a lot of different guys out there that do that. A lot of guys do it different ways. All right. So yeah, I can go and probably speak 10, 15 minutes on each one of these different strategies. Like lower right-hand corner, ultrasonic strap-on. Is it good? It's okay. It gives you kind of a range. Is it real accurate? Nope. Does it stay in calibration? Typically not. Does it require precision installation calibration? Yeah. Does the pads or the gels dry out and need maintenance over time? Yes. Does your pipe change characteristics in there to make it be out of calibration over time because you get, you don't have good water conditioning or you get buildup inside the pipe? Yeah. So, plus and minuses on all this stuff here. So knowing this well, knowing what your applications are, knowing the product well, doing the Q&A, how are you going to get all the signaling through the building, all those type of things. It's not an easy thing, and you guys deserve good cash reward for designing it, understanding it, and putting in a good system. So when you look at the architecture of the system, you got your valves up top, you got your controllers in the middle, and you got your accessory interfacers down below. So when you start looking at issues considered for high value properties, a lot of people come up to us and say, hey, we got too complicated of a system. You can't deal with what we got. We got water heaters here and there. We got electric, we got gas, we got solar, we've got, hose bibs all over the place. We've got, different pump systems on various applications. We got a strange hot water recirc type of operation. We've got, humidifiers and water misters and all this kind of stuff. Well, we've heard it all. We've seen it all. We can tell you how to mitigate it. But so other water mechanical interfaces, we know how to do it. We know what the pros and cons are. We can tell you how to do it. Pressure drop curves, obviously, proper pipe sizing, anti-scald devices, hot and cold. And just an example, I think we're the only guys that have an anti-scald type system out there. But when you look at it, yeah, you can configure it, you can require it, you can specify it, and you can custom one off the system and from a design standpoint. But you need to look at that from a safety standpoint. Are you dealing with elderly? Are you dealing with, memory care facilities? And if your mixing valve system goes down, our system, or any anti-scald setup system properly is going to be that secondary protection for the end user. Monitoring response, BMS, big issue, wired, wireless systems, RF range, wall power, battery power, maintenance issues there, lifespan of the meters, range of the meter, flow detection, talked about that with the strap-on ultrasonics, maintenance program, serviceability, performance, and then bankability of the manufacturer. Are they going to be around 5 years, 10 years when the system either needs to be added onto or upgraded, repaired? How good is your architecture before it expires? And then from an accessory standpoint for, how do we interface with water conditioning? How do we interface with RO systems that run almost all the time? How do you deal with recirc pumps, pressure pumps, well pumps, irrigation controls, tankless water heaters? So, residential to office space to commercial, you start getting more complicated, but the basic philosophy, the basic theory of operation does not change. And so basic theory of operation is, it's water over time, time, quantity, trip points, set points, things like that. So, here's a system that shows you some of the things. You think water's a simple thing. Yeah, it's fairly simple, but when you start adding controls to it, and you're there on site and the electricity's off or the router's down or water's leaking down the hallways. It's like, I want my eyes on the system when I'm near the system, and I want to be able to see what's going on without having to log into my mobile app and download the most recent application, open up and remember who's got the passwords and remember who the last person is that did the set points. It's like, dude, I want to walk up to the unit, shut my valves off, knowing that I got water that's dumping down for every 10 minutes. It's $10,000 worth of damage. So water on and off position. What's your mode change? You're on a night mode, day mode, away mode, weekend mode. So you easily see that. You see what your water flow is. see what your water temperature is. You see what your countdown timer looks like. You see what your trip rate looks like. See what the water high-low temp alarm status is. If you got batteries on the system, you see the status there. So on the left-hand side, that's an on-site display panel for one valve. So you can see how complex it could be. Is it being controlled by the local controls, or is it being controlled by the scene override from an additional hardware accessory, or is it being controlled and set up on the scene schedule from the web cloud application? So little things like that. The companies that have been around for 15, 20 years are the companies that have gone through this exercise. On the right-hand side there, you'll see one of the remote building global systems. So each one of those tiles represents a valve, or each one of those tiles represents a apartment complex or a condo, as an example. So quickly you can see it. So how easy is it to identify and look and understand what that looks like? And then do you have the diagnostics involved in your controls? On your display there on the left-hand side, we got a tile view example, and then down below we've got a list view. So if you want to see the list view and see everything that's red, that's great. The good pieces of software, they'll float all the alarms up to the top of the view screen, so you have to go through and searching through all the drilling down through all the parent-child relationships. It's like, all right, show me what I need to know. Show me the problems I need to deal with this morning. Maintenance man number one, you go out and you change all the batteries. Maintenance man number two, you go figure out why, Mrs. Smith and Mrs. Jones leak defense system shut off last night. Advanced data, go in and diagnose this stuff there directly on site or remotely. And then you have the different statuses, free versions, paid versions, how much you might be paying over the course of the life of the product. Just kind of show you one application here. So we have a dual hot cold wired application between the two, so you don't have to worry about the RF being changed, because oftentimes when you deal with RF, you deal with you guys who are in the know kind of know this. It's wireless can be good at one time, or radio frequency can be good at today. And then somebody comes in and throws a router in. Somebody throws in another piece of equipment. Somebody does something else and screws up the whole radio frequency scheme of the scenario. So most of you guys know hardwire is kind of the best above all worlds. So it shows you a hardwire system right there. It shows you a hot cold system, and it shows you the screenshot for a hot cold and the different settings there. So we got the freeze protection, we got high torque, high pressure, high temp, low temp, ultra low flow capability. And that's one of the things really that you want. Some people say they got leak detection, and their meters don't start detecting water until you hit 1.5 gallons per minute, or 3 gallons per minute, or 5 gallons per minute, or 20 gallons per minute. So you got to know, all right, what am I showing? What kind of leak can it detect? How big a pipe do I want to do this? Do I want to branch these things to the system? So from an application standpoint, this is a specification issue. Is a mechanical meter? How much maintenance am I require for that? Do I need to go and recalibrate it? So really knowing the system and knowing your piping arrangement. What does your pipes look like? And then go in and say, okay, what can I afford? What can the customer afford? You specify the Cadillac, and you let the customer start Xing off the dollar volume on it. So we can just put the valves down at the bottom of your risers. We can put the valves and the leak detection systems on all the branches. So really what we're seeing a trend, if you kind of want to know kind of the trend across the United States, it's a lot of the cities and jurisdictions and states that are requiring metering of all multifamily or subtenant metering on the water side, knowing that the psychology of it is that when you meter, when you make the customer pay for their water, they use 20 to 30% less water. You'll hear that stat over and over. That's the reason that they're, making these things laws. Okay, we got a water restriction here. What's the easiest way to solve our water restriction problem? Make your people use less water. How do I do that? You bill them for it. Well, in order to bill them for it, the piping's got to be configured so you can bill them for it. Stacks and risers going straight up the center of all the multifamilies are not going to be conducive to billing each of the tenants for whatever water they use. So obviously, it's guys that are bad stewards of the water. You don't want the guys that are good stewards of the water pay for the bad guys. So your piping arrangement is going to really depend on everything. This is an example of the hot water recirc application. We call this a primary, secondary application. So on the cold water side, you got the water metering, a tier 4, tier 5, type device where you add your outside of the pipe water detection on your hot water side pipes. And then what you do is you can isolate, let's say each one of these floor levels or one condo. And you can isolate one condo alone, and you don't have to negatively affect the hot water recirc configuration of the condo below it. So you got to think about that, when you do start shutting water off and valves off. Who do you want to become a nuisance to, and who do you not want to become a nuisance to? So that's a selling point. It's a selling point on the property. It's you put a new building in, and you got leak detection in there, and hey, I'm going to isolate your specific condominium, and any leaks that you have I'm not going to have to shut the pipes off for every other condo or landlord or tenant or anybody going up and down the facility, whether it's office space or multifamily. So 8 reasons to design leak protection in every project. Undetected leaks, clearly it's going to cost you money whenever you find it. Pinhole leaks are going to become big leaks. Number 2, risk mitigation maximizes occupant productivity. I've had a roof leak here at a facility right here, and it's like the roof guy just can't figure out where the leaks are. So when the water starts coming from the roof straight down onto our computer system, it severely hampers productivity in the office. So, imagine huge leaks where you've got huge tenants, whatever, attorneys, insurance clients in these tall buildings, and they start getting leaks. Here's a stat that you can run to the bank on. 70% of occupants of a space, when they're severely causing disruption in their business, they will not renew that lease. They'll move everybody out of that building and say, this is an old building. It's unhealthy, or it's unworkable for our system, and they go and move off. So you want to maximize your productivity. You want to minimize your turnover, like number 5 right there. You want to reduce insurance deductibles. We talked about that. You want to maintain your water claim coverage. We talked about that. You want to lower your maintenance and overhead expenses. It just naturally shows that if you can find the leak when it's small, you're not going to have these, $100,000, $500,000 claims. And then number 7 oftentimes gets overlooked as well. Maximize the building loanable value. So when you get let's just say an apartment complex, and you start reducing the amount of water that your tenants use, you're going to reduce those expenses. You're going to increase the profit margin on that property. And so the bank is going to therefore say, okay, I can loan you more on that property, because you can sell that property for more money when you want to get rid of that property. So just, one little case study, condo association in Georgia. I can't remember what we had, maybe a couple of hundred condos in a downtown environment. They were dumping $7,000 worth of water down the drain every month. $84,000 was at 12, yeah, $84,000 a year worth of water down the drain. So the engineers did their job great. Any type of leak they had on this one fixture, it would go down to the drain and wouldn't cause, disruption. It would be managed water going down through the drain, but cost them a ton of water. So when we installed this system for them, it's like, hey guys, your system's not working. It's showing you got water flow. We said, buddy, we hear that every day. We hear that 10 times a day. Install the system, you got water flow. It's not my problem that the plumber can't find the source of the water flow. It's the plumber's problem to find the source of that water leak. And when they ended up finding it, it was a $1 million over 5 years, essentially, with everything else associated with it. The payback on that installation was 8 months, 18 months. So when you talk about ROI, it's like you have to kind of do some what if sort of guesstimation, and then maximize tenant satisfaction. That's just kind of obvious there. I can go. How much more time do I have, Zach? Help me out here.
We still got a fair bit of time. You got like 10-15 minutes.
Got it. Okay. I want to leave some time for some Q&A. So Typical ROI calculation, again, leak cost range $25,000 to $100,000 to $1 million per incident per floor. Normally people don't take action until they have pain. And when they start making the claims, when the insurance company starts giving them pushback, okay, let me go look and see what it takes to install a system. Excuse me. So, if it's $2,500 per space or $10,000 per floor condo, example, 20-story building, whatever, depending on what tier level that you install, $40,000, $250,000 for the system. 1 year if you avoid one leak. All right. 1 year if your deductible is $250,000 per incident. So all these questions you got to ask the customer. What's your deductible? How many leaks have you had? How many different fixtures do you have? What's your risk look like on the project? How old is the piping? Do you know where all the piping is? Do you know where all the valves are? Do you test your valves? This might be a good time to install all this, but the biggest thing that we see when we install a system, it's one of the biggest things that's really been kind of surprising to me is a lot of the automatic water shutoff stuff. A lot of the customers are not real kind of keen on that. They want to create they don't want to do the artificial intelligence stuff. They don't want to do the self-learning stuff. They want to be alerted when the settings go off and allow themselves in the middle of the night to say, okay, let me call my concierge desk. Is it big leak, small leak? And then they push a button. They roll out of bed, push a button. It takes 30 minutes to get to the site. Middle of the night, water's off. Not a real big hassle to the tenants, landlords, whatever type of space it is. They show up. And so that's the biggest thing. It's having the ability remotely to quickly turn a portion of the valves off, zone the valves off, turn the whole building off, whatever, until you get to the site to inspect it. So that type of thing, it's kind of hard to put an ROI on. Florida housing complex, these guys were getting leaks. The building space, I think, was probably, 20, 25 years old by this time. The type of piping they were using, I think it was CPVC. And so, the stuff was, it was getting bad and the valves were going bad. Incident once every 2 months, 150,000 damages to the elevator systems, individual units over a 6-month time period. After we installed it, and I think we probably had this thing installed about 3 years now. And I don't think they've had a claim in 3 years. I'm not saying that this, again, is 100% foolproof because we put 98% plus on kind of the average on it. So again, depends on where you install it, how you do it, and what the responses are. But ROI on that was, 6 months to a year. Okay, so this project right here, these guys flooded their whole penthouse. They had some tanks go out, some valves go out, some hot water heaters go out. And so we just installed some, hot and cold devices on there and some, actually these guys installed some camera systems. So when they get leaks on there, they turn their camera systems on, they see how big of a leak it is or if it's a real leak. And if it is, they can just, again, push the button, go to the job site and see what the area is and what the extent of the danger looks like. So we explain why water detection is critical in most buildings. Okay, so even in that warehouse example I gave you before, a lot of times the insurance companies will say, hey, go over these guys keep having leaks, see if you can help them out. So we go to these warehouse locations, and this one application was it was actually the fire suppression. So fire suppression leaked. I think the pipe was 80 years old, and they were getting leaks, and it was a storage place, and so they had a big claim. But you walk into the space, and they've got, again, lockers and men's and women's restrooms on one side of the warehouse, and same on the other side. And you have offices up front. So you just walk the job, figure out what your risk looks like, see where your fixtures and pipes run, and give them a simple system that's whatever, $50,000 to $150,000, and solves the problem. So typically that's kind of where we get involved on the backside more than the front side. So again, we're asking the specifying community to think of it, pipe it in, consider it in the front side. Your piping may be more expensive to do it that way, but it's going to be way less expensive and allow you to do a much more comprehensive leak protection system once the building gets older. Identify which buildings are greater risk. We talked about that. It's higher fixture to square foot ratio. Describe differently tiered systems. So, you guys can get a copy of this. It's recorded. Get a copy of that pyramid. And what I find is when I'm doing trade shows, that pyramid is such an easy way to educate the end user developer. So use it to your advantage. And it's an extremely good way to do it. Highlight the basic operation of flow-based leak detection system. So let me talk for a second right here because we have a couple minutes. There are a number of units out there that claim to be machine learning and artificial intelligence. One of the biggest fields that we are involved in is multifamily high-rise condos, high net worth individuals. Insurance companies say, hey, we got these rich guys that have got a condo in Toronto and a condo in San Francisco and a condo in Florida and a condo in the Bahamas and a condo. You can't be at all places at one time. And so, if you're not in that location, how is your machine going to learn the normal water use of that system? All right. It takes typically, and when you look at the algorithms that people use, it takes typically 1,500 events to then kind of learn the system. All right. And again, like I said, if you learn the system when it has a leak, it's just not good at all. So you have to determine that you don't have any leaks, your pressure is holding, everything is good. Then you set the thing potentially on machine learning, and the system's not going to work for 30 days, 45 days. I've got some units on my test wall that have been up there for 2.5 years, and it still hadn't reached the 1,500 event cycle trigger to say, okay, now I'm going to start working. Now I'm going to start doing what you bought me to do. So flow-based system, it's like, have the installer who knows the system, set it up to where, okay, it makes sense. If you get too many false alarms, broaden your parameters a little bit. Use a little bit of human intelligence until the artificial intelligence kind of catches up to the operation. Summarize relevant consideration for building owners. So you guys should be able to, take these 8 points I gave you, have conversation with your developers, insurance carriers, all the different stakeholders, and have a good ROI discussion on that. And then again, evaluate the risk and potential return, based on cost, benefit, those type of things. So that's really the end of the presentation. If you guys got any questions based on what I've shown you, feel free to pop them up and go through, and we'll go from there, I guess, Zach, right?
Yeah, I mean, I'm sure we'll have a couple of questions come in. I'll ask the kind of first most obvious one. In terms of that pyramid, obviously there's always a cost benefit analysis. You did a great job of highlighting the leak differential and in terms of like the 10% to 40%, and then 90% and 98% for the flow and point based systems. What is just a general say cost analysis of a tier 1 versus tier 5, or a tier, say like a tier 2 versus tier 4? Like, is it magnitudes of cost over, or is it relatively similar, or is there a way of saying that?
Okay, so let me give you an example. Yeah, great question. So I'm just going to say tier 1. All right. So tier 1, 10 to 15% effective. All right. And how do you mitigate that 10 to 15%? What you can do is you can put a superior monitoring and notification system behind it. So if you've got a superior monitoring and control system behind it, where, example, floor 1 common bathrooms get wet, I notify the concierge. Concierge doesn't respond. I notify the building engineer that's supposed to be there on site. He doesn't respond. I notify the facility manager. He doesn't respond. I notify the building, whatever, project manager, something like that. So if you've got that tiered type of back notification on there, then you can make up for that. So it's kind of a loaded question, but if I'm just going to take the hardware alone and say, let's just take a building that has $100,000. If I put point sensors all over the bathrooms and the water heaters and the locations where you have fixtures, and let's say it's $100,000, your tier 4 and tier 5 may be, $250,000, maybe $500,000. All right. How easy is it to get to the valves? can you actually valve off the critical location? So, but that's kind of a rough order of magnitude, maybe at 4 times, 1 time to 4 time type application. But again, if you take your tier one and you backstop it with a superior monitoring, reporting, and notification thing, because we got our system. It's like if the first guy didn't, we rotate to the 5th guy on the top of the totem pole. We start rotating again until somebody answers the phone, clicks yes, clicks that I've went and looked at it. I've looked at it, I've noticed it, and then I've reported. Is it a false alarm? Is it real? Was the mop bucket spilled and created this false alarm, or was it a real leak that I had to respond to? So, all the documentations that's involved with that, doing the reporting for the insurance company to document that. So that's maybe too long of an answer for you, but yeah, common question.
It really highlights the concern, right? Like, are you kind of just kissing the ring of leak detection because you're getting a slight break on your regular insurance? Or are you truly concerned about the high cost of a leak? And that's really going to determine what level you're going to. I think obviously the flow monitoring with shutoffs is quite clearly a tremendous step above in terms of actually executing leak defense. If you're just looking for, detection and an alarm, then yeah, the point with some sort of distribution system that notifies a concierge. But having lived in condos for decades around the city of Toronto, there's certainly a lot of turnover at concierge, and they've got a lot of other pieces on their plate. They're not necessarily your engineering guy.
Yeah.
They're not going to be the one that's really going to go into your mechanical room, identify the valve, have the confidence to shut off whatever. And as the owner group, do you want to trust them for that?
You're exactly right. Yeah, when you evaluate a building, you have to ask all those questions. Who's doing the maintenance, who's doing the observation, and it's small operations, 10, 12, 20 condos. It could be the guys that are retired there that are, they get a check off sheet. Okay, I'm responsible for knowing where the shut off valves are, and so you're exactly right. Yeah, it gets sort of complicated over time.
So listen, I know we're kind of wrapping up on the time here. I didn't see any additional questions coming in. I did want to just very quickly, because I recognize we're already at time here, show how they can find these products on the ATS SpecTool or within the Watts Spec Hub. If you have an account for either of them, they're both free and easy to access. Once you are on the web page, just go to the login button, and that'll pop you over into your dashboard. I will quickly highlight before we get into that, you can also access our learning hub and go to webinar recordings. And this is going to give you the ability to reference back to the presentation we had today. It'll be hosted here later on in the week. Once you are within your account, you'll see you'll be logged in as, in this case, I'm here as the demo engineer on our account. You can see our demo engineer account is quite regularly used, 91 projects so far this year, 7,000 products specified. I don't know if anyone is specifying as much as the demo account, but it'll show you your metrics both within and compare and contrast to the people within your office. Of course, you do share an account, so if you are working within ATS engineering, then Keith and I could both share projects back and forth, and those would be accessed here on the left on your dashboard. Here you've got your quick specs if you just need a single fixture selection. You've got your ATS templates, which is like our versions of a master, our recommendations on product based on application. You can have your firm's masters set up here. If you're setting up your own masters, I do recommend you reach out to me and my team. We'll help you get the masters accurately set up and take a lot of time off your hands, so you can experience just the wonderful efficiency and savings of creating a project and then dragging and dropping from your master into that project. And I'll show you that real quick now. You can see we've got our leak defense webinar demo that I set up earlier. It's got location, it's got application selected to it. So I've selected Toronto, Ontario, and office buildings. From here, you can see I've already put in a leak defense system. But if I want to add another one, let's go to create new drawing. And then really you could pin your favorites, but in this case, I'm just gonna pin my leak defense, or you could search for leak. We'll go into this leak defense category, and you'll see we've got all those different levels that we talked about today. So let's go with inside and outside the pipe, leak detection with alert, and the auto shut off. And if there's configurable options here, then we would include the options, but we're just going to add the product, and it's going to build a fixture chain of all the other pieces that we need for this level of selection. So we're going to get our controls, we're going to get our API, we're going to get the polls, all those different pieces. Here we've got our flow leak detector that we can select our pipe size. So we talked about 2-inch during the selection. Let's do hard wrought wired, because as you mentioned, that's kind of our best version. So now we've got our shutoff valve selected. It's going to pipe in and bring in the rest of the fixture chain. So there we get our point of leak detector, where again, we can select any options that we need to select. I think battery powered is more common for the point of leak detector, right?
Yes, sir.
No, I assume the defense, the control module probably tells you when your battery's getting low, notifies you to change those batteries. All that will be built in there. We'll get our wall panel. And to prevent walking through all the additional steps, I'll jump back over here. You can see now our live project is, shows you how far we got along the system. We can call this leak defense system 2. Of course, we can move everything up and down, reorder, delete, and then we can add more. So, this is one aspect of the component, but if you want to round out the rest of your selection, if you're building an entire project, yes, you've got your leak defense. Now, how quickly can you build in the rest of, let's say, a Class A office? So this is where your masters come in. I'm showing this using our ATS templates right now. But if you have your masters in here, it'll work the same, where you can check the boxes of the products you wish to have in your system. So let's do our fixtures here. And then you simply drag and drop those 7 into your fixtures tab here. If we wanted to do a drainage tab as well, we can go check all the boxes. Maybe I don't need this trench drain. I can drag and drop these drainage pieces into a new fixture, into a new product group. And now in a matter of minutes, I've used either the ATS recommendations for an office or your internal firm's masters to create a standard office building, general fixtures, general drainage, that then I can also show my custom selected leak defense. Obviously, this gives you a lot of ability to either configure the individual selection or utilize your approved masters that, if leak defense is in your new condo master, then you can drag it over as you go build a new condo project. Once you're done, you would just hit select all drawings to download, or just choose the drawings within your product group. You'll see this goes into an orange button. We can then download our submittal, our schedules, our long specs, short specs, manufacturer specs, Revit, CSI 3-part spec, all those different documents that you'll hit generate. But as I always anticipate that I'm running a little bit behind, I've pre-downloaded here. So you can see we've got our leak defense webinar demo. This is the manufacturer spec sheet format. Gives you them all numbers of what we've selected. Shows you the manufacturer spec sheets here, and the manufacturer spec sheets on this package, because of how specific this leak defense project is, we do have these, that pyramid in the title page. Nice custom package that you can walk through with your owner group, show them the important key details. And we've got a little bit more detailed, some middle spec. If you need a written spec, we've got that in 3 different formats. Here you can see the CSI 3-part spec, where we've got our description of the system, Tier 4 hybrid system, RT4, This will show up in a different formatting as well, a little bit more generic formatting that they can everything's open and editable. Copy and paste this into your written specs. If you were doing a schedule, this will show up in schedule as well. You'd want to show what the schedule look like. One of the great things about the ATS schedule format is that you get multiple tabs based on the different application type. So if you're doing a backflow schedule, a floor drain schedule, all those different schedules are going to come with different information along the top, different column headers based on the type of schedule that you're using. And of course, everything's going to be configured to your actual selection. So it's not a generic system most of the time. It is custom and configured to the selection that you've made. So if you need help getting your master up on the system, please feel free to reach out to me. I will help you get an entire master up so you can have the benefits of just dragging and dropping on your next new project. If you would like a specific deep dive into this topic for you or your firm, if you have an upcoming project where one of your condo owner groups has been asking about leak defense, or maybe they're just doing that really basic low-level leak defense and you want to give a complete comprehensive system, reach out. We'll be happy to tag in the appropriate personnel, set up a joint call so that we can all discuss the project, help you get not just the spec, but the actual right components for your application. And of course, if you're joining us again for the next ATS University, we'll see you in a week or so. Thank you very much, Keith. That was great. I learned a lot. I know that we'll have the list of attendees over to you, and you and the Watts marketing team can get those AskVCU credits out to people as they try to get all their credits for the year. But thank you very much for joining us. If we don't talk to you, enjoy the upcoming time off for the American Thanksgiving, and all the best to those that attended with us.
Oh, dude, great job, Zach. Really appreciate it. Take care.
Have a great rest of the day.